ஆல்ரெடி பிஹெச்டி பண்ணியிருக்காங்க. இதில் அவங்க இந்த இதில் எப்படி இன்னும் கொஞ்சம் அட்வான்ஸாக பண்ணுறதுன்ட்டு படிக்கிறாங்க. மேட்லாப்ல இமேஜ் ப்ராசஸிங் மட்டும்.
என்னோட தீசிஸ் வந்து ஆப்ஜெக்ட் டிடெக்ஷன் டொமைன் அடாப்டேஷன் யூசிங் டொமைன் அடாப்டேஷன் சார்.
ஓகே.
என்னோட தீசிஸ் எம்டெக் தீசிஸ்.
அப்படிங்களா?
ஆமா. ஃபாஸ்டர் ஆர்சிஎன்என், கான்ட்ராஸ்டிவ் லேர்னிங், டொமைன் அட்வைசரி லேர்னிங் அந்த மாதிரி அதை யூஸ் பண்ணிட்டு.
சரி, ஓகே.
தீசிஸ் எழுதின்னு இருக்கேன். 28th and 26th அன்னைக்கு இது பிரசன்டேஷன்.
ஓகே.
ஓகே, அதான். ஆனா எங்க கேம்பஸ்லயே வேலை கிடைச்சிருச்சு. ஆனா இருந்தாலும் ஜான் டியர்னு ஒரு கம்பெனில இருந்தாலும் கொஞ்சம் நம்ம ப்ரிப்பேர்டா போலாம் வேலைக்கு. அதுக்காக தான் இதை சூஸ் பண்ணாங்க.
ஆமாமா.
அதான் சார். அதுவும் அந்த வேலையும் எம்பெடட் ஆட்டோமோட்டிவ் இதுதான் கோர் தான். அதனால
அதுதான் படிக்கிறீங்க எம்பெடட்.
அதான் சார்.
சரி சரி, ஓகே. So okay, we'll start the class. Okay. Only seven of you present, I think. Yesterday and Friday, who did not attend the class?
சார் நான் அட்டெண்ட் பண்ணல நேத்து கிளாஸ்.
நேத்து அட்டெண்ட் பண்ணலையா? சரி சரி.
ஆமா சார். ஆனா அந்த பிடிஎஃப் பார்த்துட்டேன். சோ அதை வச்சு கோப் பண்ணிடுறேன் சார்.
சரி, ஏதாவது டவுட்னா கூட கேளுங்க. சரியா?
ஓகே சார்.
அதே நான் பர்சனல் நம்பர் தான் இருக்குல்ல, கால் பண்ணி போனா கேளுங்க.
ஷூர், கண்டிப்பா.
So yesterday we are discussing about the LCD display, no? So LCD display is what? What is the use of application means? So just see the output, okay? So whatever function, present function or past function, so continuous function, whatever may be, okay? If continuous function means currently what is the temperature at present, that we can monitor in the LCD display, okay? Past function means how much previously, how much historical record. In PLC industry, the historical record will be there, okay? So previous record that will be stored. If you check means it will show how much, okay? That's the thing, okay? So what is the difference for using 7-segment multiplexing or whatever may be multiplexing 7-segment and this LCD display means in 7-segment we will see the output only the numbers, okay? But in LCD the text we can see, okay? That's the thing, okay? Actually the text, okay? So whatever text, a line, okay, you can see. So that's in the display. Yesterday I told you, sun mark, sun Myanmar, lots of display, dot matrix expose, LCD display, crystal display. So even IPL match you can see, So whenever Virat Kohli or Dhoni, if hitting 6 minutes, they will send a message, So these and all different types of displays, okay? So scoreboards, railway stations, okay, and even the traffic lights. So lots of displays have. Every display is having some X codes, okay? So before going display, I want to tell you some. I want to draw the 8 signals, okay? 8 waveforms I'll draw, okay? So after finishing that waveforms, so just you tell me which one is the AC signal and which one is DC signal, okay? So in embedded system, the microcontroller is working on the DC only, okay? So operating voltage of PIC IC, how much? What is operating voltage of the microcontroller? For PIC 16 of. So for ARM, how much? ARM. Can you tell me ARM?
3.3.
3.32.
Yes, yes. LP, ARM IC LPC 3148. Yes, 3.3 volt. Okay. So other some advanced IC it works on 3.3 volt. Okay. So anyhow, so this basic thing we know, but anyhow now so while checking the hardware, so you should not know only the coding. Okay, you want to know about the hardware also. Okay, without knowing the hardware, how you will do the program. So correct no. So sometimes no, the hardware engineer they will give the result some of the waveforms. Okay, so externally or internally or supporting files, supporting components. What is the waveform? By seeing the waveform, you have to judge. Okay. Then yeah, now I'll share my screen. Everyone can see my screen, my laptop screen. It is visible to you all.
Yes, sir.
Visible now.
Yes, sir.
Okay. This is the first signal. So here I have drawn 8 waveforms. Okay. So tell me which one is AC, which one is DC waveforms. If it is wrong, also no problem. Okay.
First one AC signal.
Okay. First one AC.
And second one is DC. Step signal like that.
Yes. Then
Third also DC, sir. That is an AC to DC converter. And
fourth one.
mm, mm, fourth
All
one
out.
also, I think, the balance, I think, remaining are DC.
So what is your name?
Augustine,
Yeah, Augustine. Okay. You are from which place?
totally background, sir.
Which state? You are Chennai or Tamil Nadu?
Today, Tamil Nadu, sir.
Tamil Nadu எந்த ஊரு?
தூத்துக்குடி சாயர்தான் சார்.
அப்படிங்களா? சரி சரி. எங்க நீங்க படிக்கிறீங்களா, ஒர்க் பண்றீங்களா?
நான் படிக்கிறேன் சார், சேலம் கவர்மெண்ட் இன்ஜினியரிங் காலேஜ்,
என்ன படிக்கிறீங்க?
தேர்ட் இயர்.
ஈஸிங்களா?
ட்ரிபிள் சார், எலக்ட்ரிக்கல் அண்ட் எலக்ட்ரானிக்ஸ்.
ஓகே ஓகே. ட்ரிபிள் படிக்கிறீங்க. ஓகே ஓகே. அதர்ஸ் எனி கெஸ் which one is AC waveform, which one is DC waveform?
Sir,
Any-
second,
think,
third,
yeah.
sir, second, third, and seventh is DC, and remaining all are ACs.
So second, third, and seventh
Seven.
is
Yes.
DC, and remaining is AC.
Yes.
Okay. Ashwini, you are from which state?
Sir, Maharashtra.
Okay, okay. Okay, now I'll. Okay, as your point of view, you have told. Okay, so now I'll tell. Now I'll route which one is AC, which one is DC. Okay.
Yes.
So first one is AC. So only the first waveform is AC, remaining all DC. Okay. Only first one is AC. Okay, remaining all DC. Okay, how can we can find AC signal, DC signal means, see, the any waveform, it is crossing the zero. Okay, in this, see, this waveform is crossing the zero, so it is AC. Here you can see the waveforms are not crossing the zero, so these are all DC waveform. Okay, maybe this signal, no, it looks like a AC waveform. This is only the first half is a positive, negative it didn't go. Okay, anyhow, I'll tell you each and every waveform. I'll explain it. Okay, this we know, 230 volt is normal sine waveform. Okay, this we know, this is normal sine waveform. Every waveform it has name. Okay, this is sine waveform. And this is ramp. Okay, this is ramp signal. This is we call as a DC sweep. Okay, but this is waveform, we'll call it a DC sweep while doing DC sweep analysis. Okay, so what is the DC sweep analysis means? Whenever, for example, you're designing a circuit. Okay, that circuit is completely, it is a DC device. Okay, that circuit is working in battery. Okay, like mobile phone, laptop, remote watch. So these devices are all working only in DC. No, so to find the operating voltage of the circuit. Okay, See, you can't give the laptop battery to the phone. No, it is impossible. And you both are working in 5 volt only. You can't take the laptop battery and you can't give for the mobile. And you can't take mobile battery and you can't fix to the laptop. Okay, both have different features. No, so it won't work. So what is the use of the DC sweep analysis means? To find the operating voltage of the circuit. Okay, for example, you have designed the DC sweep. Okay, further the DC sweep, how much DC sweep the battery required. So if you give more high voltage, what happen? The circuit will burn. If you give less means what happen? The circuit will not work. Okay, for that circuit it has to work. No, watch for that. How many battery voltage we can give? That is how many battery supply is required. Okay, that to finding that only there is a DC sweep analysis. Okay, and this is a bandwidth. Okay, this is a bandwidth. So this is bandwidth is used to find the audio frequency range. Okay, so I'm speaking in now I'm speaking. Oh, you can hear my voice clearly. Okay, so what is the reason means our audio frequency range. So every laptop, phone, while speaking to anyone else, their voice is you are getting clearly. So the reason is they will in this electronic device they will set the audio frequency range. Okay, the audio frequency range want to be 20 to 20 megahertz. Okay, sorry, 20 to 20 kilohertz. Okay, that is the audio frequency range. This is not a waveform. Okay, a waveform will be inside. It will be like this. So the uh, so this is called AC sweep. So this thing will I'll teach you another deeply. Okay. So I think this is called this waveform is bandwidth. This is ramp signal, the AC. And fourth one is pulsating DC. Okay. This is called as pulsating DC. One minute. This is called a pulsating DC. This is full. This is full wave rectifier, and this is half wave rectifier. I think this pure DC. Okay. So this thing put, and this is the square waveform. Okay. This is the output we are getting from the IC. So this is a important waveforms. Okay. So now why I'm telling this waveforms about means, so every microcontroller needs this signal. And this is seventh one, no? This pure signal. Maybe it is 5 volt or 12 volt. Okay. So mostly microcontroller needs 5 volt, no? For that, for that we are using we need this 5 volt signal. But how we will get the 5 volt signal? Okay. So while you are designing, no. So for example, while you are designing, you are using microcontroller. So microcontroller needs microcontroller input needs pure 5 volt DC. So how will you design manually means? So sometimes you don't have adapter, okay, or any power supply circuits you don't have, okay. So at the present, immediately you have to do, okay, for while doing some R&D or research. So I'll tell you, okay, and this is the pulsating DC is capacitor, okay, capacitor's output, okay. From the capacitor, the charging and discharging will be happen, okay. So what is the use of what is full rectifier means what? Diode, no? From the diode, diode's work is what? It'll in the first
Convert
class
AC
side.
to DC.
Yeah. So diode will do it'll convert it invert AC to DC. Okay, it's a rectifier. From AC to DC, it'll convert. After even converting, we can't use that. We can't use this waveform. Okay,
Waveform.
see this waveform we can't use it. Correct? No. The diode's work is it'll change from AC to DC. But even though we can't use this waveform, okay. Now I'll tell next thing how to use this waveform. Okay, this is half a rectifier. Two diodes using. Okay, so this is IC. From the IC we'll be getting op amp or any logical IC. We'll getting this IC signal. Okay, so anyhow now, so here I'll tell you the how to get from. Please, for example, here the microcontroller. Okay. So this is a PIC microcontroller. Yes, so this is VCC pin. Okay. So in this pin, I want to give 5 volt. Okay. So this PIC microcontroller, I need 5 volt DC. Okay. So this 5 volt DC, you can directly we have the adapters. So devices. You, I'm telling about when the emergency period. So you are somewhere else. Okay. Immediately you want to uh, uh, check the IC is working or not. Okay. Already it's programmed. Okay. Some programmed IC you got it. You have to check that whether you have flashed the program into the IC. Okay. You are having only the IC. So you have to check it. Okay. For checking purpose, you have to give power supply. No, without power supply, how will you check the output and all? So definitely you want to give. So how you can check means, okay, this is the power supply. Okay. This is 230 volt. Okay. In our home or plug point, how much you're getting?
230.
230. Okay. So in India we are getting 230. So some other country will be getting 220 like that. Okay. So 230. So here we are getting the waveform like this. 230 AC, okay. This 230 AC you can't give to the microcontroller, okay. It is not impossible, okay. So what I am going to do? Next step, I have to step down this 230 to 12 volt AC, okay. So, so directly 230 volt AC 50 hertz I can't directly give to the microcontroller. It won't work. Okay, microcontroller need DC volt, 5 volt DC. Okay, so what I'm going to do? So I'm going to make the step down. Okay,
So step down transformer.
yeah, correct. So now what I do? I fix a transformer. Okay, so 12 volt step down transformer. Okay, so we having 24 volt step down transformer, 12 volt. So we need we can use 12 volt. Okay, so now my I'm getting my output here like this. Here getting 12 volt AC. So what we did from 230 volt to we step down the voltage. Okay, yeah, 12 volt AC we get, but even 12 volt AC we can't give to our microcontroller. No, pick microcontroller. Pick microcontroller need 5 volt DC. Okay, and the output want to be like pure DC. Okay, so this output I want to give to the microcontroller. Okay, this output is pure DC. Next, anyone tell me what we next step next we can do?
AC to DC. So we can include a
Yeah,
rectifier.
correct. Rectifier. For rectifier, we can use diode. Okay, that is
Right,
called
yeah.
bridge
Off-way
rectifier. Bridge rectifier. You can use it.
Then that is full way rectifier, right?
Yeah, this is full way rectifier. We need both AC and DC. Full sine wave, no. Positive and negative we need. For that we are using.
Bridge
This is
way.
one diode. Half wave means one diode. Full wave means two diode.
Four. Okay. Bridge rectifier we are using 4. Yeah.
You are using bridge rectifier. Okay, here we will use bridge rectifier. In mouse, drawing won't be good. Okay, so imagine. Yeah, I'm connecting here. Okay. D1N4007. So diode number. Okay. Okay. Anyway, we connected D1N407. Now I will get my output like this. Okay. Now 12 volt AC. I'm getting. Okay. So now I'm getting 12 volt DC. So 12 volt DC I'm getting, okay. Some 232 we made it 12 volt AC. Step down on that. From AC to DC we convert into AC to DC if I'm using rectifier, okay. So this is a rippling pulse, okay. So we have to filter this, okay. We need pure straight line like this. Pure straight line like this. Okay, so now so what you have to do? We are going to place one capacitor, okay. Say 1000 microfarad. So after so this is plus and this is minus, okay. So after placing the capacitor, then my waveform I'll get the waveform like this. Okay. So this is also 12 volt DC. So now, so see in the after converting the bridge rectifier, so I have reduced the rippling. Okay, this waveform called pulsating DC. Okay, this the capacitor from the capacitor we're getting the output. No, that is called as pulsating DC. So now what you are going to do? Anyone tell me now what we have to do? Any idea? So now we have to use voltage regulator. Okay. Yeah, use the ground. This in, this is out. This is ground. Here we are using LM 7805. Okay. Because we need 5 volt here. Here the peak microcontroller we need in for VCC 5 volt. Okay. So after using this LM 7805 regulator, okay, this is the regulator. Every development board, this will be okay. LM 7805. First pin is input, second pin is ground, third pin, whatever input getting from the first pin. So in this circuit, we are getting here 12 volt. We are getting no the output here will convert to it will regulate to 5 volt DC. Okay, here we'll get 5 volt DC. Here we're getting 5 volt DC. Even though say we have some mild surges, okay, noises are there, okay, we're not getting pure 5 volt. So even though you use regulator, it'll now you are here we are getting 5 volt. Okay, 5 volt DC you are getting. This side 12 volt and this side 5 volt DC you are getting. Okay, anyhow 12 to 12 volt DC to 5 volt DC, the voltage regulator it regulated. Okay, but anyhow that 5 volt not pure. Okay, some surges are there. Okay, some spikes. So you have to reduce that spike without filtering the spike. You give to the microcontroller means what? It won't work properly. Okay, for that what you have to do? See, anyhow I'll show this kit. So this is the PIC 16877. You know. So here can you see this corner? Can you see no voltage regulator? Can you see here this corner? Everyone.
Yes, sir.
Yes, sir.
Yeah. You see from this here. This is the power jack. In the power jack, this board. See, so this I see you want to give what? How much voltage? 5 volt? No. So that we can't directly on give the 5 volt. Okay. Here you have to go 12 volt. Okay. That's in the adapter. This particular section will be there. So here from the 12 volt, what happened? This voltage regulator, this will reduce to 5 volt, 12 volt DC to 5 volt DC. Okay. Here directly we are getting DC. Okay, because we are not adapter. Sometimes you are not having adapter or any electronics filtering devices means at the time you have to do this. I'm drawing no. This you have to for emergency period. At the time you can't be you can't be without doing anything. You can't do it. Okay, you can buy it from the shop. You can immediately so you can make ready a power supply for microcontroller. Okay. So see this is the voltage regulator. From this voltage regulator, so already one capacitor here, no? This is that capacitor. This capacitor already from the DC it is reducing, and here to avoid these surges, we want to put another DC, a small capacitor. Okay, and then we have to close with resistor. So mostly they will give 10K. Okay, after placing capacitor, whenever when you're closing the circuit, we have to place with the resistor. Okay, without closing the resistor, you should not directly take the output. Okay, now we can what happened? Now we can give the output here. Okay, so from this point, we can directly we can give the output to the microcontroller. So I'll tell you here how what is the waveform. Okay, here we'll get the pure 5 volt DC. Okay, pure 5 volt DC we are getting. Okay, to get the normal 5 volt DC for the PIC microcontroller. So this much process is there. Okay, So here no, instead of 5 volt, you can remove this voltage regulator. If you placing LM7812 means you will get 12 volt output. Okay, or 9 volt LM7809. If you use 9 volt, 9 volt you will get. Okay, so this is a process to get microcontroller for input voltage getting the 5 volt. Okay, it is a power supply and a voltage regulator. So already we have that filtering capacitor here. Okay, so by the capacitor it will reduce, and from the resistor here, can you see the resistor, load resistor? From this is the power supply unit for the microcontroller. Okay, from this it will come, okay, directly to the this microcontroller. Okay, so this is the LCD. Today we are going to see about the LCD. So in this board, what are the analysis you have seen? Anyone tell me? In this big board, what are the
7-segment display,
7 and then
button, push button. I mean, that
push
might
button?
be keyboard. That
Which
might
one?
be keyboard. 4x4. Yeah, keyboard. Yes, keypad.
Keypad you
Okay.
finished.
Tactile screen.
Noted. But I have remember.
The keypad you, no, I'm not asking. I'm asking what are the sections in this board. I'm not asking. Till now, what are the class completed in this?
Okay. So
I'm asking that. Okay.
push button is done. So
Push
LCD
button, LCD, and
7-segment display.
7 segment and this one, multiplexing. Okay.
Multiplexing. Yeah.
Only
This is a
push.
multiplexing.
Yeah. In this is multiplexing. Even if you want, you can use 7 segment. I thought, and motor you wouldn't study. No, motor, DC motor, stepper motor, servo motor. That you till learn, no?
Noted. I guess.
Okay, only you learn basic structures and ports. Okay,
LED. Yeah, the different LED connections and a push button, which is pull up and pull down.
Yeah, okay.
Pull up.
Okay.
Yeah, pull down. So and 7-segment display. Push button also.
So push button. Okay. Next we'll learn LCD. Okay, LCD keypad we'll learn. Okay, and motor drivers. Okay.
A motor we are going to use relay.
Yeah, we want to learn DC motor, no?
Okay, no need of relay. Okay.
So see here, this is a stepper motor driver AC. Can you see? This is a driver AC. LM290 motor driver AC.
Oh, stepper driver. Okay.
So, not for stepper, for all DC motor. DC motor, stepper, servo, and a DC motor. For that, this is a driver AC. Okay. So directly from the microcontroller, you should not give to the motor. Okay. By using the driver only, we can use it. Okay. And USART will be set a USART, serial communication. Okay. And the LCD display now today will see keypad. And the ADC. Okay. Analog to digital converter. Okay. And I2C, SPI. This thing will be, this will see. Okay. RTC, real time clock. Okay. And this is the main thing, connector. Okay. Another important thing I want to tell is this is our microcontroller. Now 1 minute, wait. So in this board, we will, you see this. This is a diode. Okay, this is a zero diode. So you can see my cursor on there. There is a zero diode. Okay, some boards will be normal signal diode. I'll tell you what is the reason for that. Okay. Here we have this voltage regulator. So it is standing now by using a heat sink. Okay. You don't know what is use of heat sink. When it get heat means that heat will be dissipated in this aluminum metal. Okay. So that's the reason they're using this heat sink. Okay. You can see this is a crystal oscillator. Okay. So without this crystal oscillator, the entire board it won't work. Okay, because this frequency is very much to the IC microcontroller. Okay, here we have the diode, Zener diode. Okay, so I tell you what is the use of diode. Okay, here this is the receiver transmitter max driver AC. Once again, I will check one other example board. Here you can see the diode. Okay, so this is the driver AC, and this is a diode. Okay, but anyhow, in the hardware you can't perfectly get it. Okay, so anyhow, I'll tell you why. What is the reason diode is using? Okay, see for example, see this PIC microcontroller want to control the motor. Okay, so this is a motor. Okay, so motor is given to the ground and power supply. We can't directly give the PIC IC to the motor. No, it won't work. Okay, so there will be a driver IC. Okay, so from the driver IC only you will give. Okay, from the driver IC, from the driver IC, a relay. Okay, a relay. From the relay only it will come. Okay, relay will act as a switch. Okay.
Yeah.
Relay,
So
relay
we
will
need
act as
to give the external supply for this
yes,
to
yes.
motor, right? Because
A
the 12 voltage it won't work.
yeah. Motor will work in the external. No, motor will work in 230 volt. Okay.
Yeah.
Only we
So
want to make switch to on and off. Okay. Motor will work in the externally. Okay. So even if in your home we are using for water motor, we are using motor. No. Eh, So sometimes we'll be using water level indicator motor automatically. If tank level gets below means automatically what happen? The sensor will sense and give the instructions to the microcontroller and the motor will on. Okay, and the tank is getting filled means again the sensor will give the instruction to the microcontroller and then what happen? And then motor will get off. Okay, that's it. So anyhow, I'll draw the clear picture here. Okay, so this is a microcontroller. So motor is out, our external. Okay, it is a motor. This is plug 230 volt. Okay. Yeah, we're getting 230 volt AC. Yeah, we're given that 230 volt phase and neutral. Okay. So what will go from the any port? Any port. So driver is L to 9 3D. Okay. So this is motor driver AC. Okay. L to 9 3D is the motor driver AC. Okay. So from the microcontroller, we have given the supply to the motor driver AC. Okay. In the coding, what will be written when to off, when to on, when the motor want on, when the motor has to be stop. For that purpose, we'll be using. Okay. Another thing for driver, driver AC, if you give the signal means motor want to rotate forward means that is for separate X code is there, and motor want to rotate reverse means for that separate X code is there. Okay, so that way I'll teach you while going to the DC motor, servo motor, stepper motor. Okay, that I'll teach you separately. So we from the by return the coding, the X code is given to here. Okay, so we are connected to the stepper motor. From the stepper motor, the supply is given to relay. Okay, relay they will be normally open, normally closed. Okay, so this directly is given to the, yeah. This is common. This is normally open, normally closed. Okay. Another one is connected here. Okay. So the as per the instruction, the driver IC will give the instruction. Then what happen? This IC will be activate. This relay will be activate. After relay activating, the supply will go here and motor will run. If you want to stop the motor, there will be a no common that will cut the supply. Okay, then supply won't come to the motor. Then motor will stop. Okay. So relay functional I'll teach you later on. Okay. Now why I'm taking this topic means the important diode. Okay. What the diode is doing in this portion. Okay. This we have relay coding on and off, that coding that we have separately. So now no. So you have to check it here. Okay, what will happen? So when the you switch off the circuit, okay, continuously the motor is running. So once you switch off the circuit, what happened means in this relay no. So I'll show the relay type. these all the types of relay. When I first as I have told you about the relay, okay. Think and you know everyone know about the relay function, okay. When it's supply come from the microcontroller, this coil will be energized and the supply will go. When no supply will come, it will again go to normal position, okay. Like that, relay will be working, okay. Can you see inside the relay? We have a coil, okay. See, number of more than thousands of turns is there, okay. This much copper coil core is wounded, okay. It is coiled. See, whenever no, you switch off the supply inside the relay in this coil, what will happen? The current will be stored, no current. So this, if a small line conductor, nothing will happen. So this much of coil is wounded. Okay. So what happened when you switch off the supply? This stored energy, no, what will happen? This stored energy, the stored energy will directly go come here. Okay, it'll come here. It'll come here, and what happened from this coil? The stored energy directly come hit back this driver AC. So what happened? The driver AC it won't work, okay, because the heavy current is, it will come reverse, no. So driver AC will spoil. To avoid that only we are using the diode, okay. So that's only we are using diode here. If you place a diode here, what happened? Diode only forward direction. It won't come reverse, okay. Reverse it will block, okay. Only it will go the forward direction. When reverse, it will block it, okay. It won't allow again the reverse current from the coil. It won't allow go to the our L293 driver AC, okay. It will stop it, okay. For that reason only they are using the diode, okay. Now you understand now what is the use of diode in the microcontroller. So every microcontroller diodes will protect the microcontroller pins, IC pins, okay. Because the reverse current will be following whenever from the relay and all. Because mostly all the output will be working in the relay only, okay. Switch, instead of switch we are using relay. From this coil, what happened after switch off, shut down? That from the coil, the current will be coming back to the IC, okay. To avoid that, it will stop the reverse current, okay. To blocking only, to block that reverse current, we are using the diode, okay. And another thing, that too, what type of diode we have used, there's a thing is there, okay. In diode we have IN, mostly said it's signal diode, okay. IN 401, 2, 3, 4, 5, 6, till 7 we have, okay. See, you see, if it is 100 volt, we can use 1. If it is 200 volt, we can use this. If it is 300 volt, we can use IN03. IN004 means 400 volt will block. Then 500 volt will block. If 6 means 600 volt will block. IN407 means it will block from 700 to 1000 volt, okay. For example, here we are getting, for example, here this is diode. Here we are getting 500 volt. Okay. So we have to use IN4005, 6 or 7. Okay. Instead of 5, 6 or 7, you're using IN4002 2 means what happened? It can't block it. Okay. So you have to check how much voltage is coming. Depends upon you can use these numbers. Okay, for blocking. So this is the important things of diode to protect the microcontroller. Okay, this is the basic things you have to know. Why we are using diodes for protection purpose. And next we'll go for LCD. Okay. I will, yesterday I told you about the LCD. Now we are going to see about normal 16x2. Yeah, you can see the LCD. Okay. I think everyone know what is the full form of LCD. Everyone know. No? If anyone don't know,
Liquid
still I
crystal
tell.
display.
Yeah, that's correct. Okay. Liquid crystal display. So 16 column, we have 2 row and 16 column. Okay. And these are the D0 to D7. We have this data signal pins. Okay. And another thing, we have a read write enable. Okay. uh, For the allow the data to input. Okay. First, we'll see the structures of this LCD. So this is the normal structure. Okay. So VSS, the first pin is ground. Okay. So we have to give the microcontroller will get the 5 volt separately. For this LCD display, we need 5 volt separately. Okay. So first pin VSS, first pin is ground. Okay. So we have to give ground. This is the ground LCD pin. Okay. And the second one. Okay. Second one is VCC. Second pin is VCC. The source pin. Separately, we have to give the power supply for that 5 volt power supply. Okay. In the Proteus, we'll take the power source and we have to connect it, and also in the same the for VSS from the Proteus, we have to connect the ground pin, ground supply. Okay. And third pin is yeah, third pin is control pin. Okay. Adjust the contrast of the LCD. Okay. Mostly sometimes by using the pot resistor, we can adjust the contrast of the LED. Sometimes the contrast will be very bright. As to reduce that, we can use it. Okay. Now, 1 minute, wait. And then and this is the very important one. Fourth, fifth, and sixth. Okay. Fourth pin is register select. Okay. Fourth pin is RS, register select. This is a control pin. Toggles command data pin. Okay. See if connected to the MCU. This will be connected to the microcontroller, and pin gets either 0 or 1. If 0 means command mode trigger. Okay. 1 means data mode. Okay. And RW. This is what is fifth pin. RW read write. Okay. That is another control pin. Toggle the LCD between read and write operation. Okay. This is also will be connected to the microcontroller. Any port will be connecting. Okay. Data pin will be connected to the A port or B port. So mostly no. This D0 to D7, these will be connected to separate port, and register, read and write, enable. These pins are will be connected to the separate port. Okay. Because we won't mix it because we have only 8-bit port. No. So this 8-bit will connect to separate port, and this 3 will be connected to separate port. So I'll show you while doing now. And this is the sixth pin is enable pin. And this is the pin 6 enable pin, control pin must be held high to the performance read write operation. Okay, whenever read write operation running, it should be high. Always it should be give 1. Okay. Connected to the MCU microcontroller, always held high. Whenever enable is high only, this function will be done. Okay. And remaining D0 to D7, 7th to 14 pin. Okay. Pin 7 to pin 14. Pin 7 to 14. Data pin used to send the command or data to the LCDs. Okay. So whatever text you want to display, man, that data that is sent from microcontroller to LCD from this data pins only. Okay. So we have already told now we have 4-wire mode and 8-wire mode. We call it at 8 and 4-bit mode and 8-bit mode. We call it. Okay. See if it is 4-wire mode means uh, D7, D6, D5, D4. It is connected to the microcontroller. If it is 8-wire mode means all D0 to D7 it is connected to the microcontroller. Okay. That is called 4 mode, 8-bit mode, 4-bit mode. Okay. And 15 pin, 16 pin the LED, normal LED operation like illuminate the LCD. Okay. That is connected to the 5 volt. Okay. Positive and negative LED negative. And if you turn back, this is the back side of the LCD. Okay. See, this is the top side of the LCD. Back of the LCD will be like this. Okay. But in Proteus, we'll be using only this symbol. In real time, it will be like this. Okay. So this pin is directly fixed in the our development board or our devices. This is the back side. Okay. Back side, this pin was inserted in the board. Okay. The LCD back side will be like this. Okay, and now we'll, I open the program and we'll do it. Okay. First, I'll open the software and I place the program, and then we'll see the programming functions how it is working. Okay. So open the project. I've selected the family Pix 17A. Select this tech tool. Next. LCD 8 bit mode. Okay. To the project name. Next and finish. File new. Just make it save as. Okay. So the go .c file. No? LCD 8.c. So whatever name you can give it. Okay. That is a C file. No. Select the source file. Right click. Go to add file. And do the LCD 8 dot this C file. Okay. Open. So it is connected. I'll place the programming here and then I will see it. Program is placed. I will check the program whether we have error or not. Okay. So after compiling it, we'll see the programming lines and hardware. So build successfully. Okay, and rebuild it. I'll explain the coding now. Before explaining the coding is done by the following by the hardware. Okay, so we have to know about the hardware now. How the our Proteus microcontrollers hardware is connected. How it is that you have to know. Okay, before that we'll so the fix 16 IC. This is the hardware connection. Okay, told you this is 8-bit mode. Our B port B0 to B7 that is connected to the D0 to D7. Okay, and register read write enable that is connected to this C port that is connected to C0, C1, C2. Okay, that's all. For this, we no need to give ground and all. Okay, automatically software will take rotation will give. Okay, real time we have to go. Even sometime if you see some Proteus diagram, the VSS VDD and VSS is connected to the ground, the VDD is connected to the power symbols. That we no need to give. Okay, directly we can go. So now we'll check the coding. And this is the pick. As usual is microcontroller header file we are given. So here now the RS register read write enable that is declared to the C0, C1, C2. C0, C0, C1, C2. So that you have declared. Okay. And here we are declared hash different delay. Okay, we are given delay for a micro using loops. So we need loop no. A loop function we have given this delay. Okay, a loop function. And here integer j declare integer variable for j. We are using integer for that we have given the used the variable j used to delay macro. Okay, and this is the function prototypes. Okay, so void LCD initialization. Okay, so this is void LCD initialization. This is a prototype for LCD initialization. Okay, so for LCD we have to initialization. No, for that we are using. And another is void CMD unsigned character. A. This is a prototype for the function to send commands to the LCD. Okay, so for LCD you have to send commands. No, for that we are using this. So next one is void data unsigned character B. This is a prototype for function to send data to the LCD. Okay. And this is void show unsigned character. So we are given the pointer S. Okay. That is a prototype for the function to display a string on the LCD. Okay. So what we are going to make it? We are going to send a string. Okay. So why that pointer? So whatever string we can going to use. Okay. Not fixed. Okay. Any we can change the string. Okay. For that we are using that. So another this is config. Okay. The config FOS. What is the config FOS? That means configuring microcontroller oscillator. Okay. For this config in the pick microcontroller oscillator, we have to use it. Okay. And anyone tell me what is WTE? Have you heard about WTE?
Watchdog. Watchdog.
Yeah, correct. Okay. Watchdog timer. Okay.
So we have actually, sir, we have old IDE, I guess. In that these configurations we have it. I mean, we can get it from the below. There is an
Yeah,
option. It will show that we can get it from there itself.
that direction we can get it. Okay.
We do usually that these
Yeah, yeah.
configurations and everything. We make it as a hub. Yeah.
Yeah. This is generally we'll be using this. Okay. This is a watchdog timer. And then from TLBP. This is generally these are the operation we know it. Okay. We're making it off. Okay. For this LCD, we don't know it. This and all. Okay. And here now, this, so we are going to the void main, the main function where the program starts execution. Okay, from here. And unsigned in integer I. Okay. So declares. So it declares an unsigned integer variable as I. Okay, we are declaring it. And what is this? This B.
Setting
This
B port as
B port. No. B port and C0, C1, C2. Okay. Taking output, setting B port and pins and C0, C2 as output. Okay. This three one.
output.
Okay. Because this is connected here. No. This one. All the LCD, not only for AVR, Atmega, Synergy IC, ARM, okay, Atmega 32, Atmega 16, Atmel, and this PIC 16, 18, this all will be the same concept. Okay. Only a little bit syntax will change. Other than these and all, same only. And here, then LCD initialization. So LCD initialization, this is calls the LCD initialization function. Okay. And this is the command 0x8a. Yesterday I showed no. So can you see here? This is the LCD commands. Okay. The LCD command. This is a standard. Okay. So for all the LCD 16x2, the standard commands. Okay. So even here export. This is all for the working condition of the microcontroller. They manufacture all the LCD. Okay. This will be common. Anyway, you just go to the Google, type LCD command 16 cross 2, it will come. Okay. For that function, you have to go that command only. Okay. So you can type go to LCD command 16 cross 2. So this is the standard commands you can see. Okay. So what is 0x8a? Posing the cursor at 0x8a position. Okay. Posing the cursor at 0x8a position, it show. We can see here 0x8a. Check where is 0x8a. Yeah. Here it is. So here 0x. So this is not 8a. This is we want to check 8a. Okay, we'll check. Eight zero is there. Eight. Oh, or else you can just type and see. LCD command 0x8a for LCD cursor spawns on cursor on. Okay, it will make display on or cursor blinking. Forcing the cursor at this position. Okay. So here, welcome to EOT. Anyone tell me what is EOT? You know what is IoT? Okay, what is EOT? Everyone know what is full form of IoT? Those who don't know
Internet
IoT,
of Things,
yeah, what is EOT?
electronics of things.
Yes, correct. How you know that electronics of things?
You just guess it.
Yeah, because I have prepared this EOT. Okay, I'll show the syllabus. Okay, I have created a EOT syllabus to launch for the colleges. Okay, to study EOT, you can go for IoT field, PLC field, robotics, embedded. Okay, whatever. Okay, and this is for the display. There. We have mostly we have to do double port. Okay, this double quote, what we display again. We turn to so this thing we have to display, okay. And this is the infinitive while I, okay, is an infinitive loop for this one, okay. Y equal to 0, I less than 1500. This is a loop again. Is it a delay loop, okay. And this is for command 0x18. What is that command? Sends command to shift display left side, okay. But you have to check it. It is the coding. You have to see in the data sheet now. What is this? You have to check in the data sheet, okay. 0x18. Here it is now 0818. Shift entire display left side, okay. It is from left hand side, okay. Normally our string, if you want it is shift from the right to left or left to right. So we have placed it to the left side, shifting the display from the left hand side. Okay, it come from the left side. It won't go to right side. Left side will display, okay. So that's the thing. So welcome to embedded. That will come from the left hand side display will come, okay. And this is the void LCD installation comments, okay. Command, see 0x38. We'll see what is 0x38. The second one. So 0x38 is a 8-bit mode. This is 8-bit mode, no? We have connected D0 to D7. So this is 8-bit mode. So making this LCD to 8-bit mode, we have given this. Command 0x0C. We'll see what is 0C. What is 0C? See, so this is the 8th one. See, this display on, cursor off. Okay. When LCD is getting on, the cursor no, it will blinking in the middle of the string. That will make disturbance after when the LCD is getting on, the display will be hide, okay. That cursor will be hide. So that's why display on, cursor will be off. It won't in the middle of. Okay. And command 06 entry mode, okay. It make the data to enter into the whatever data string, it get entry mode to the LCD. And command 0x80. Here 0x80 force cursor to being in the first row, okay. Can you see here? Because this is a 2-row, no. See, 2-row 16 column. So the text will become display in the first row, but it comes in the left hand side, okay. So and this is a void command unsigned character, okay. So this is the void command unsigned character A. So this is a port A, no, port A we have given. This is LC release. So what we will do, we'll mostly register will be 0, read is 0. We'll make the enable 1 and then we'll make the enable as 0, okay. This is the command function. We'll set RS as a pin to 0 for command mode and RW as 0 to write mode, and we'll make enable 1 to set the enable pin 1 to enable the LCD. Okay. Same thing will happen for the void data. Okay. So void data, what will do? It is connected to the port we know. For void data, set the data pins to the data value pin. So see RS to 1. Set the RS pin to 1 for data mode, and read write to set the read pin to 0 for the write mode. Okay. Again, we have to do set the enable to 1 to enable the LCD. Okay. Again, we have to make it 0. Then finally, what? To void show the character. Okay. Send each character of the string to the LCD. Okay. By string increment. Okay. So this is point of whatever string you can give. Because there is 16 process. No. So one by one, the string will be increased. Incrementally will come. Draw the hardware. Okay. Go to the I'll send this coding and notice email to your group. Okay. Okay. LCD. Connect the D port to RS. So now we have connected everything. Okay. Now we give our X file. So this is our X file. And run. Okay. So this is come from the left hand side. Okay, that I given the command like that. Okay. The string we have given. String we are given. This got run. Okay. After changing, I didn't compile now. That's why it's not coming. Okay. Previously it is EOT. I not compiled. Okay. Now I have compiled. Now I'll stop it and run. So now a string is what string I have given, that is displaying. Okay. I will everyone tell the attendance. Okay. 1 minute. I will show the attendance name list. If whose name is not there, send me your WhatsApp me. Okay. Tomorrow I'll add it. Whose name is not here? Tell me. Tell your name.
Sir, my name is not there. Yuvraj. Yesterday also it's not there, sir.
Okay. Okay.
Mine as well, sir. Balaji. Yes.
Balaji. Balaji initial.
Yes.
Okay. Afterwards you send the email. Okay. Any other name? Not there.
Yuvraj, yes.
Yeah, you can add my name. Arvind.
Arvind.
என் பேரும் ஆட் பண்ணுங்க அரவிந்த்.
உங்க பேர் என்ன?
டிஹெச் டிஹெச்
TH-ஆ?
அரவிந்த் டிஹெச் டிஹெச். ஆமா.
இன்னொரு அரவிந்த்.
இல்ல ஒரே அரவிந்த் தான்.
TH-ஆ?
டிக்கு பதில் டிஹெச் போட்டுடுங்க.
ஓகே.
Yes. Then Kumar at 2.
Instant.
Kumar. Arvind Kumar.
Any other else? Here it is. இங்க இருக்கு பாருங்க.
Yeah, that's spell that only. That.
ஓகே ஓகே. நம்ம
Adan.
இங்க இருக்கு. So tell your attendants, Aravind.
Yeah. I'm daily presenting. Daily வரணும்.
Daily. Okay.
So Friday also I came. Friday and yesterday.
Yeah. Every day நான் இருக்கேன்.
Saturday, Sunday, no, not there, no. So Saturday, Sunday.
Saturday, Sunday class இல்லைல்ல.
Okay, ஆமா 17, 18 இல்ல.
ஆமா class இல்ல.
Okay. Saturday, Sunday நீங்க ஃபிக்ஸ் பண்ணலாம். ஓகே.
Okay.
Any other attendants?
Augustine, sir.
Augustine.
Mohammed.
Okay. Mohammed.
Bỏ số em.
Yuvraj.
I'm good. That's all.
Yuvraj.
Yesterday came Yuvraj.
Yes, yesterday and day before yesterday also. Friday, Monday, all day present.
Yogesh Kumar. Okay. We'll see tomorrow. Okay. Bye.
Thank you, sir.
Okay.